Good day, everyone. I am Danica C. Palacio, BS in Science 103. So, I am going to tackle all about Fibonacci sequence. So, what is a Fibonacci sequence? A Fibonacci sequence is a sequence where its first two terms are 0 and 1. Each term thereafter is obtained by adding the two preceding terms. So in Fibonacci sequence, the first two terms are 0 and 1. But how can we find the third term of the Fibonacci sequence? This is by simply adding the two previous terms. 1 plus 0 is equal to 1. 1 plus 1 is equal to 2. 2 plus 1 is equal to 3. 3 plus 2 is equal to 5. 5 plus 3 is equal to 8. 8 plus 5 is equal to 13. And the pattern continues. We only have to do to add the two previous terms. So in Fibonacci sequence, the first term is denoted by a 0. The second term is this one. The third term is next. The fifth term. And the pattern still continues. So what if we are going to find the ninth term? Ninth term is denoted by how can we find the ninth term or the f sub 8? This is by simply adding f sub x plus f sub 7. So where is the f sub 6, 8, 7, 13. So the ninth term is 21. Therefore, f sub 8 or the ninth term is 21. So let us continue. Now we are to find the nth term of the Fibonacci sequence. What is the 13th term of the Fibonacci sequence? Remember that we are to find the 13th term. The rule to find the 13th term is to add the previous term, 13 and 8. We are going to start here. 13 plus 8, 21. 21 plus 13, 34 plus 21, 55 plus 34, and 89 plus 55. So let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 144. Therefore, 144 is the 13th term. Another way to find the nth term is to use Bernoulli's formula. this, and this. So, for computing the derivative term of finding the nth term, you just have to use scientific calculator for simplifying. Hi, it's me, Danica C. Palacio again, BS in Science 103. So now I am going to tackle all about my next topic, which is the measures of dispersion. So the first type of measures of dispersion is what we call range. The range is the difference between the greatest data value and the least data value. So the formula in finding the range is highest value minus the lowest value. The second type of the measure of dispersion is the variance and the standard deviation. So in variance and standard deviation, we do have differences. We have population and the sample variance and standard of deviation. For the variance, for the population variance, we have sigma squared is equal to the summation of x minus mu squared over n. While in the sample data, we have s squared is equal to the summation of x minus x bar raised to 2 over n minus 1. So, here's the standard deviation. The formula in finding the standard deviation is, in the population standard deviation, we have sigma is equal to the square of the summation of x minus x bar squared over n, while the sample standard deviation, we do have s is equal to the square of the summation of x minus x bar raised to 2 over n minus 1. So the third type of the measure of dispersion is what we call the coefficient of variation. The coefficient of variation is the percentile expression of the mean and used to compare variation of different sets. So the formula in finding the coefficient of variation is the standard deviation over the mean times 100%. So let's try to solve the problem. Find the range, variance, and the standard deviation of the given sample data. Remember that the given is a sample data, not a population data. So, if we're going to recall about the formulas for the range, we have the highest value and the lowest value. So first, let us determine the highest value for this numerical data. For this numerical data, we have 15. 15 is the highest value and 2 is the lowest value. So 15 minus 2 is equal to 13. Therefore, our range for the sample data is 13. Next, we have to find the variance. The variance of the sample data. Remember that we must find the sample mean first in order to compute for the variance. For the sample mean, we have to add all the numerical data divided on how many numerical data are. 2 plus 5 plus 8 plus 10 plus 15 over 5. 14 divided by 5 is equal to 8. So 8 is our sample mean. Now, let us compute for the variance. Let us put all the numerical data under this. We have 2, 5, 8, 10, and 15. Now, let us subtract all this by the sample mean. 2 minus 8, 2 from this, and 8 from the sample mean. Negative 6. 5 minus 8 is equal to negative 3. 8 minus 8 is equal to 0. And 10 minus 8 is equal to 2. 15 minus 8 is equal to 6. Now let us find the product, or the square the product of this. Negative 6 times 6 is equal to 36. Negative 3 times negative 3 is equal to 9. 0 times negative 0 is 0, still 0. 2 times 2 is 44. 7 times 7 is equal to 14. All in all, we are going to calculate all of this using a scientific calculator. All in all, we have 98. So 98 is 98 is the summation of x minus x bar squared. So now let us continue for the formula of the variance of a sample data. So this is the formula of variance in the sample data. S Now, what we're going to do is to just substitute. So we're going to substitute the summation of x minus x bar squared, which is 98. So from this formula, we got 98 as this is the summation of x minus x bar squared. Then 5 as the number of numerical data. So we have 1, 2, 3, 4, 5 minus 1 as prior to the formula. So 5 minus 1 is 4. Now we have 98 over 4. So, when we have computed 98 over 4, we do have So, we have 24.5 as the variance of this sample data. So, after we have found the variance of the sample data, now we are going to find the standard deviation of the sample data. Let us recall first the formula of the standard deviation in the sample data. We have S is equal to the square root of the summation of x minus x bar squared over n minus 1. As we recall, we do have 98 as our summation of x minus x bar squared. We do have the square root of 98 over, as we remember, all of the datas are 5 in all. 5 minus 1. And we come up with this idea. 98 over 4. Now, we are going to find the square root of 24.5 using a scientific calculator. Now, our final answer for the standard deviation of the sample data for this problem is 4.95. So after we have found out for the variance, standard deviation, and the range of the sample data, now let's go on to the coefficient of variation. So for the coefficient of variation, we have a different example from the example we had earlier. There are two machines. One uses the hexakinase method and the other one uses glucose oxidase method. Which method is more precise? So by determining the more precise method, we have to use the coefficient of variation. But let us first understand and analyze the table. The analyte for method A is glucose and the analyte for method B is also glucose. The method for the method A is hexakinase and the method for the method B is glucose oxidase. However, the standard deviation for the method A is 4.8 and the standard deviation for the method B is 4.0. And the mean for the method A is 120 and the mean for the method B is 100. So the question is, what is the coefficient of variation of method A and method B? In method A, we have standard deviation over mean times 100, 4.8 over 120 times 100 is equal to 4. We have a coefficient of variation of 4% for the method A. However, for the method B, we have standard deviation over mean times 100%. Standard deviation is 4.0 for the method B. And mean for the method B is 100. So 4.0 over 100 times 100% is equal to 4%. So as what you can see, 4% for the method A and 4% for the method B. Therefore, they are equal. Therefore, we can deduce that both methods are precise. Both methods are precise by calculating the coefficient of variation. Thank you everyone for watching. Hope you guys learned something for today. Thank you.